Hi guys, in this video I'm going to talk about sentiment analysis using machine learning. I'm going to be using Python for this, and this is the project which I made, and I just made some modifications so it's looking like this. The font size here is a bit less, so I'm going to be showing this in Notepad++, and yeah, so sentiment analysis is one of the most popular things, quote unquote things, which you can do with machine learning. And here in this project, I have tried to use sentiment analysis to determine positive emotions and negative emotions, um, based based on the tweets. Like the tweets, this model is going to determine if the tweet has positive emotion or negative emotion, positive sentiment or negative sentiment. So this is what this project is doing. So this is the output. I have just run this code for about a minute or 30 seconds maybe, and it gives 800 results, so it's pretty good. So as you can see, this is an example. Like if the tweet is, "I promise that our administration will always have your back," and whatever. So this statement, from this tweet, we know, we as humans, we understand that this is a positive sentiment, but there's no way for machines to understand that. So for that, we're using machine learning, and the model is pretty accurate because it detects it's a positive tweet. Then the next one, "Congratulations, Secretary Mattis," and it's probably since word "congratulations" and it is guessing that it's a positive tweet. This algorithm is not 100% foolproof. Well, nothing is basically, but it gives a good result. But it does not work flawlessly, but it works. And I've made this algorithm. Sorry, I didn't make the algorithm. I made this program in about 4 hours, so it's far, far, far from perfect, but it works. It basically works. So, well, while making this program, I had encountered a few issues, and basically, I'm making this video to talk about the issues. Well, um, if you've seen this video about sentiment analysis, probably you are not a beginner. Well, even if you're a beginner, you can probably grasp the concepts if you are a quick learner. But yeah, probably assuming that you're not a beginner, and I'm going to link all the resources which I used for this program. I've also mentioned the resources here. This is the resources, and I've opened the resources in a browser, but unfortunately my Firefox is giving some trouble. Apparently the Firefox is giving us a lot of trouble, and my WAMP server is running, which it should not basically. And let's close the torrent also. Okay, I hope it works now. Okay, it's not. Anyways, so basically, if you open this first site, and it is Vidya, uh you will, if you read it, you will understand that for sentiment analysis, naive based classifier is probably a very good algorithm. It works. It's not the best because there's some issues with it. They're dealt in depth in this post, not in depth, but yeah. But it naive Bayes is probably a good algorithm for sentiment analysis. This is one paragraph which I have taken from this website. It's explains what multinomial is. Like, um, it is used for discrete counts. For example, let's say we have a text classification problem, like in our situation. Here we can consider Bernoulli's trials, which is one step further, and instead of word occurring in the document, we have count how often words occur in the document. So multinomial is probably a good algorithm. Like the variant. I'm not really a machine learning geek, so I'm still learning. Anyways, so this is the website. Oops, nope, no, it is this one, the second one, but it's not. It's frozen. Anyways, So basically I'm going to explain first. Am I recording? Please say I am. Please. Okay, yeah. So first thing is we have to train our model, and then we have to test our data, like we have to test it on the test data. So for the training purposes, the data is here. So this is my training data which I have got from the website, which is, where is the website? The website name is, come on, yeah, it is dataworld slash dataset slash Twitter. So I got the data from this website. I have opened this in the browser, but it's not opening right now. This is the website, the fourth one from the left. So you have to train your model, and then you have to test your, you train your model and then you have to test your model. So basically this is what machine learning is. But the model, the test data, sorry, the training data is, first is a word, then is a positive, then is a negative, then is a bad. Like if it's a positive, it's going to be 1 or 0. If it's a negative, it's going to be 1. If it's a bad word, it's going to be 1, else it is 0. So as you can see from the first word, a word can neither be positive nor be negative nor be a bad word, which means essentially means that it is a neutral word. So there are many neutral words here. A model will be trained on that and it will decide later. So I'm using pandas here because it is easier to extract data from CSV files using pandas. Let's see if our browser is working. Not really. Okay, anyways, so I'm getting the data using pandas. So period read CSV, with this function gets the data from the file name. The file name is train data CSV file CSV name. I did not write comments in this code because I've used variable names which are quite descriptive, so you don't really need comments. And I've read somewhere that the best code is when you don't need to put any comments, so it's attempt in that direction. So the training file name is put here, then the columns you use, like the use calls, which means the columns which I'm going to use from the file name. And then for the words, like for the words like this one, for the words, for the words I need column 0, then for the positive I need column 1, the negative column 2, then the bad column 3. So this is getting the data from the file. The next step is to train our model. And the dog is barking and disturbing my video. Okay, okay, thank you. But the problem with this is this algorithm, needs uh it needs integer as its input. Then the test, the this is the x, this is the y, this is the um test, this is a target, this is a data, this is a target. So like it needs integer here, but our data here is text, it's not integer. So we have to do something to convert this text into a corresponding integer format so that the function can use it. For that we need these 4 lines. We are using count vectorizer. This I have also linked in the resources section, and I've opened the website but it's not opening. Anyways, okay, this is the website from where I got the data. So here, this is it, and then you can probably see it later. So we need these 4 lines to convert our text data into a corresponding matrix format token count. I don't want to go into that, but just know that to use text data, use text data, you need to convert it to corresponding matrix format, and for that we need these 4 lines. This is there in the Sklearn material, the documentation, and I've linked it in the description also. But and I opened it here, but it's not opening. So I've linked in the description, like not this one. Okay, I will link it in the description. Anyways, so we need this basically. So considering we have done this, this is the we have converted our data into a matrix format token, that's our token count. Then we are creating the three objects. I don't know if they are objects or not, or what they are called here, but these three variables are basically like uh, CLF positive, CLF negative, CLF bad. Like we're training our model based on the matrix data and the output, like the positive, we're taking the positive, putting it here, the negative, putting it here, and the bad, I'm putting it here. Like the positive, negative, and the bad, the three trained models. Like this is going to train, these three lines are going to train our model, the positive, the negative, and the bad. So what this basically does is, like, now if you're trying to use this model and you put in some test data, like to predict, then we're going to use this variable name dot predict and pass in the test data, and then it's going to give the result. This is this thing probably you know if you are watching this video. And then this is the output file, like file where we want to save our data. And then yeah, this is our output file, yeah. And then tweet file name, this is the, what exactly is this file? 2017 Trump tweets CSV. What is that? Trump photo. Okay, this Trump text basically means is, what is the Trump text? This is the one. This is the test data actually. As you can see, this is the test data. All this is test data. So so test data, and where is it? Yeah, the test data, and we are opening the test data with encoding UTF-8. Probably better you do this, otherwise you're going to land into some problems. Actually this data here is basically UTF-8, but it's not really UTF-8. I mean, there are some characters which are not recognized, and it's going to give some issues. So the UTF-8 is going to do a better job than the regular one. The regular is CF something, I don't even remember. The errors, ignore the errors and as F. Then for line in F, like put this in a try catch, it's better. Otherwise I encounter a lot of errors, and program actually froze once it finds error. So better put in a try catch. Like if they finds an error, it's just going to skip the line instead of stopping the entire program. So basically what it's doing is getting a temporary string, and it's calling the function get emotion from text and passing the line. So we're going to print in the line, and then we're going to dump the data to the output file. So now let's see this function get emotion from text. What the hell? Okay, okay. So get emotion from text, what it's going to do is positive is equal to get emotion text CLF positive. Okay, this function is again using another function get emotion. So let's find out what this function does. So what this get emotion function does is it expects a text and the CLF. This is the model, and text is equal to text. The split is going to split the text into it's going to basically make a list from the text, and x new count is equal to count vector or transform. This count vector is made here, count vector, and it's going to transform. Okay, I'm going to go into bit depth here. It's like x train counts is basically fit transform. Fit transform means it's going to fit our data according to, it's going to fit our data and do some magic with it. This is fit transform, and this is only transform is going to transform the data based on the already manipulated data. Let's put it in this way. And actually I have to explain something more. What this fit transform function expects is expects a list of strings, but I didn't really find any function which gives me a list of strings from a pandas data frame. So basically I made one. So let's see what I've written here. It's pretty easy actually. So it's expecting a data frame, and then for s in data frame dot values means for all s, if length of s greater than 0 means there were some entries where there were no words, and it caused a problem. So let's see if there are some words, at least one word, and if there is at least one word, we're going to append it. So this is it. So this is the transform is all the things already fitted. It's now transforming this new text according to the previous fitted model, and then this is the x new. This is it's actually there in the documentation. I just copied it. It works like in this way. The features and account vectorizer. If you read the documentation properly, then you will understand that these functions are there when we need them. Then predicted is equal to clf dot predict. Then the okay, this is the thing, like this is the text and this is the matrix representation of the text, and we need this if you are going to use it. So yeah, predicted is equal to some clf that predict, the model that predict, and then it's going to predict. Then positive count is assigned to 0, means the number of positives. So if for x in predicted means for the output, if x is 1, then we're going to increase the positive count and just return the number of positive words in our sentence. This text is basically sentence. So we'll get the number of positives, the number of negatives, and number of bad, because you're passing in the model of positive, model of negative, model of bad. If bad is greater than 0 means if there's at least one bad word, I'm assuming that this the tweet is basically crap. It may not be in the real case. For this we need a bit more analysis, like you need more than 4 hours to do this project. Then whatever, like I assume that if there's at least one bad word, this means it's a bad tweet, and I'm just going to ignore it. Otherwise, if positive is more than negative, then it's a positive tweet, else it's a negative tweet. If negative is more than positive, then it's a negative tweet, and if positives and negative are same, assuming it's a neutral tweet. Well, basically this is not really the case. Am I recording? Okay, basically this is not really the case. I mean, you cannot just say positive is more than negative, then it is a positive sentence. No, maybe it's like if it's 62% positive, then it's a positive. It's a 20% positive and maybe 40% negative. It's still a positive. There may be research like that, but this can be done. Like if we get to know this exact data, how much positive is actually positive, how much negative is negative, and all this, we can probably do that. But the basic idea is we're getting the things done, and that bit mathematics, if we get the data, we can obviously do that. I mean, how much positive is positive and all this data, we can get this thing done. The basic things, it is working. Basically it is working. So it is going to give me the emotion, like it's going to basically return me, like determine if it's a bad tweet, positive tweet, negative tweet, a neutral tweet, and that's it. This function does up to this. So we're getting the emotion, and then we are dumping it to the text file and printing on the console. So let's see this algorithm in action. Okay, let's remove this thing first, because it was from a previous run. Let's delete this, save this, and let's run this file. It's going to take some time because obviously the test file is 9 MB. Sorry, the test file is 3 MB. The training file is 9 MB. So it's going to take some time to train, and it's going to take some time to get the entire job done for testing of 3 MB file. Actually, the thing is 3 MB is not really very big. I have seen datasets which are 6 GB, 7 GB, and yeah, that's pretty nasty. There, the problem is you cannot open it in a text editor because it does not load in the memory. For that, you have special text editors actually, but like I'm still learning this, so I don't know that much, but I've used this only once. The big, really big files. I got that from Analytic Vidya. Like, it was a competition, and I obviously I couldn't do much. I couldn't do that good because I'm still learning. Like, forever sentence. I'm still learning, quote unquote, still learning. So as you can see, this algorithm is working pretty fast. Well, I'm saying the algorithm is working pretty fast because I've previously made a mistake here in my code, and when I was okay before this recording, I was actually recording this video one more time, like before this recording once. And the thing is, I was talking in the video, I was explaining this function. I realized my mistake, and what I was doing basically was I was creating the training models over and over again for each line I was testing my model. So, and that was the reason this program was running really slowly. And I've, as I said, I've used machine learning from the past, and I'm aware that it takes some time. Sometimes it really takes time to get the processing done. So I was patient. I did not think that um, it was my problem, but when I was explaining the code, I realized that it was a problem. Like, this was a problem because I was creating the CLF again and again and again, which I did not need to, because like once we train our model, it is done. We can use it. We don't need to keep training the model again and again for each and every text. That was basically my problem, and I fixed it, and I cleaned the code also. Okay, before I forget, I'm going to post a link to this source code in the description, and this source code also has the resources here, so probably uh yeah, probably you can understand every bit of it. And the coding is also done pretty in loose language. I mean, you can provide the variable names are good, the function names are also good, I think. So it's running. It's going to take some time to run. Yeah, let this function run. I need this complete output. So this is all for this video, and yeah, that's it. Thank you so much, and keep coding.